We might be working. We have liftoff. How about that? Okay. It's working, and I can kind of see you. I can't tell if you can see my computer screen or not. So what I'm going to do is I'm going to point my camera at the computer screen here. Kind of. There it is, way over there. They don't put it, they haven't got it up on both screens here because the system is stupid. But that's okay, I suppose. So we are into our third day of this project now, and I have received, let's see, I need to get into my, there it is. I have received drawings from lots of people, so that's great. Let's go here. If you have not turned in all three of your possible options or your what's the word they use in there? I can't remember. All three of your alternative solutions, I think they call it. Then get those in today, please, because today is the day that you need to choose one of those alternatives and begin specifying the exact building parameters of that design. So last time we were talking a lot about these generating alternative solutions and how we're going to draw very basic drawings using just lines and points essentially. One student had a question about the scale. Remember that the scale of the drawing is going to be different than it is here because here they've got the scale written up in centimeters. We want to write it up in inches. Here we have the top view and the side view. You can see both of them, and they give you instructions on how to draw those. You're going to follow similar instructions when you draw your final drawing, when you draw the detailed drawing. Now in the detailed drawing here, this is step 5, I believe, is where we're at. Yeah. So right after we're done with our, let's see, where does step 5 begin? Here it goes. When we're done with our alternative designs and we choose one, which we should choose from the evaluations. Remember, the evaluations at the bottom determine how good the bridge is based on its ability to accomplish the task it's supposed to accomplish, based on its economics, based on its looks, based on its, maybe if you model it in a computer program, based on its strength and so on and so forth. But now we're into step 5 where we will create a working model of the design that we choose from those three alternative solutions. And of course the beginning of that is a scale drawing. We have a scale drawing that is simple. We want to make a scale drawing in a much more detailed way. This drawing should be as close to a full-size drawing as you can make it. It's not necessarily easy to do with the paper that you've got, but you'll end up gluing pieces of paper together to make one big sheet for your scale drawing. And here they talk about how this is done, how you're going to tape these together for your side view, and you probably want to do one for a top view, so just make as many copies as you can, print off as many as you can. And here they talk about drawing in the joints and the members again from the alternative design that you've chosen. And then they talk about using a ruler, and this is where using a scale design is very helpful, because if you're drawing to true scale, then you can use a ruler to measure the parts that are at angles on your sheet. If you change the scale on your sheet, if we go to the end of this thing and we look at this is the final sheet that they have where 1 square is equal to 1 centimeter, and that's actually not true. This page is certainly not 1 centimeter. That's actually the revised bridge one. We want to do this one. This original one is not even 1 centimeter. These are closer to an inch. But anyway, if you if you lay out your ruler and figure out how long a distance is 1 inch on here, and you're just saying that each one of these black boxes is an inch, for example, then you have some kind of scaled ruler that you can use. So if each one of these is 3/4 of an inch, and you say that 3/4 of an inch is equal to an inch, then when you go back to this scale drawing part, you can actually use a ruler to determine the lengths of things, which is what they're doing right here. So that's what they're doing up here. So any of these members that are along the lines that are drawn right on a line, it's very easy to figure out how long those need to be. But the ones that are not, the ones that are drawn at angles, those are more difficult to do. You could use a little bit of trigonometry, some Pythagorean theorem if you wanted to do that, and that's exactly what they show you over here, where you can calculate the members. But you can also measure with a ruler. And how do you do the Pythagorean theorem? Well, each one of these angled pieces, you can make a right triangle out of. So if I drew a line straight down this way, I would make a right triangle, and then I could count up how many spaces I'm going up on one side, count how many spaces I'm going over on the other side, and then plug those in for d and e squared, d squared and e squared. Plug in, if this is 6 spaces here, then you plug in 6 for d, 6 squared is 36. And if this is 5 here, then it's e squared is 5, or vice versa, doesn't matter, for d and e. And then you add those together, and that will give you f squared. Take the square root of that, and that will give you the third side of that long angled side of the right triangle. If you've not used that before, then you should get used to using it. We use it a lot in engineering. But anyway, you can use the Pythagorean theorem, you can use a ruler, and you can use both. It's not a bad idea to check your answers by using both. But in the end, on this alternative drawing that you've drawn, this remember is the drawing that you drew in step 4, one of the alternatives that you've chosen. Once you've made those measurements on that alternative drawing, you need to start filling out the sheets for the different parts, for the different wood parts, the different plastic parts, different cable parts. Now, someone mentioned that the wood is just a little bit too small to drill a hole for the dowels that I've given you, and it is fairly small. That is true. But if you're very careful and you use a nice sharp bit and you don't force the bit through, you can make very nice holes in those strips for those dowels. If you are struggling to do that well, then go ahead and you can use some smaller dowels if you have them. If you want to buy some, that's fine. And I know that it is doable. I've done it myself, and I have many students that have done it. You do have to have a very sharp drill, and you have to be very careful that you drill right in the middle. And so it's a good idea to use pencils to mark exactly where the middle is, mark exactly where the point of your drill is going to go in, and to use a new drill bit, or at least a sharp drill bit, so that you're not breaking up the wood as you drill it. So anyway, having said all of that, this is the next step. We want to have these 3 sheets filled out with all of the parts that you're going to use for your bridge. And then, once you've done that, you start to draw your scale drawing that is to full scale if you can do it. If you can't do it to full scale because the paper is not exactly an inch after you print it out, or it's not even close to an inch, then we'll just do a larger drawing. And the idea with the larger drawing is that you're actually drawing in the individual parts, how they look. So, for example, if you're making I-beams, you should draw in I-beams. If you're using wooden dowels, you should draw in wooden dowels, and you should label them as such. And that comes down here. I guess they don't really show the example of those drawings here anywhere. I was just scrolling down to look for one and couldn't find one. So we'll go down to near the end here, back to our big old sheets. There. So on these sheets, you want to draw in the thickness of the board, the thickness of the pieces of wood that you use, and if it's plastic, you maybe draw it black, since the plastic is black. If you're using wood, maybe you draw it yellow or brown, since it's wood. I think I just got disconnected. Sorry, we got disconnected there for a second. But looks like the presentation's working better. Maybe I can you see my computer? Wave at me if you can see my computer screen. Okay, good. That's good to hear. Can you guys talk at me and see if I can hear you? Okay, I can't hear you. That's all right. If you can hear me, that's good enough. So anyway, I was just saying that when we get to the scale drawing, if you want to, I mean, if it makes it easier for labeling, you can use black pens to fill in plastic pieces. You can use brown pens or brown pencils or something to fill in wood pieces so that it's obvious what is wood, what is plastic, and have some kind of a key like that. If you want to do it, that's fine. But this drawing should be as close to full scale as possible, so you're going to end up probably having several of these sheets pasted together, taped together somehow to make a big sheet of paper for that part of the project. And you can kind of make it work out any way you want to. If it works better for you to tape 6 of these sheets together, that's fine, do it. And make the scale work as close to full-size scale as possible. Now, this part of the project, which is the filling out of the sheets that include all the parts. These sheets here, where you have one for cables, wire, strings, whatever, one for dowels, one for plastic parts, one for wood parts. Once you've filled those out and you have every part on your bridge accounted for, and every part, the length of it, any holes that are going to be drilled in it, all the dimensions of everything, once you've got these 4 pages filled out, then you are ready to make that detailed drawing, and that really is what I want you to be doing today, and have it done by the end of class on Monday probably. And so you work a little bit over the weekend to get it done, try to get it done before the end of class Monday. On Monday, I would like those turned in to me, and I will check up on them. And then Monday, hopefully we can start building. And even if you're done with those things before Monday, you can start building. You can start cutting the pieces, drilling the holes, and I would do I would prepare all of your materials before you start building, and maybe prepare a few extras of materials just in case you break something or you need to start over with something. But I would get all those things prepared beforehand, and this is the point at which you start taking pictures of the process. So when you're cutting and you're drilling and you've got different pieces, I would take pictures of those pieces. Each different piece that you make, take a picture of it, and start saving those pictures to insert into this workbook. And that way you have a visual record of what you're actually doing, and that corresponds with what you planned on doing. Then as you start building it, you should start taking pictures of different stages of the build. You should take a picture of it when maybe you finished the bed of the bridge. Maybe if you're doing a suspension bridge, take a picture of the first tower and the second tower, and before you put in the cables and after you put in the cables. Or take a picture from the top, from the side. Take lots of pictures. It's kind of hard to get too many pictures really, unless you're taking the same picture, pictures of the same thing over and over again. But you want to be able to show people what your design looks like in enough detail that they don't have any real questions about it, that it's completely obvious that your design fits, that your actual prototype fits the design that you made, and so on and so forth. So start taking pictures. If you don't have a camera, maybe use the camera on the computer that you're using. If you don't have a camera or a computer with a camera, maybe use your phone. If you don't have a phone with a camera, then maybe you can borrow one from somebody and use their phone just really quick to take some pictures, or maybe the school has a camera you can borrow. But take some pictures for sure in some way, and get those and start inserting those into this workbook at different places. The best way to do that is to fill out this workbook, print it off, and then start printing those pictures off on separate pages and just literally inserting those new pages in at different points in this workbook. They shouldn't all just be stapled on the end. They should be inserted in places that make sense. So if you're taking pictures of the wood pieces that you've cut out and you've drilled out and everything else, then they should probably go after this page called Wood Member Dimensions. And you should label each photograph, label each picture, so I know exactly what it is. This is member number D on my drawing. I made 5 of them and show pictures of it. If you're struggling to drill holes through it, you should take a picture of a failed hole drilling and a successful one and what you did take to be successful at it. Because people who are doing this project later are going to want to know those kinds of details so they don't have to make the same mistakes. So, that is where we are from Monday. From Monday, I definitely want all of these pages filled out with all the different parts, and I want you probably should be at least started on your scale drawing, maybe even done with it, so that you can start building right away. Because on Wednesday, we want to be able to start to test, if at all possible. We also have time on Friday next week. I believe that, let's check our schedule just really quick before I make any broad statements about this. Let's see, syllabus. So actually we're supposed to be, it says we're supposed to be done on Monday. It's today, man, that went fast. So actually we probably won't be done quite on Monday. So we'll probably maybe push this into Wednesday and try to cover Chapter 5 in two days, or maybe push Chapter 5 into the next Wednesday and do another take-home exam, something like that. But anyway, we'll make it work. So try to get these done, try to get these drawings done Monday so we can start building Monday and hopefully test by Wednesday at the latest. And maybe you'll get them done quickly, maybe not. This is the first time I've actually taught this class in this way, where I'm stepping through the projects one step at a time or a couple steps at a time. I've not had a lot of success just giving people the project all at once and letting them go with it. So I'm trying a different approach this time. So it'll be kind of, you guys are my guinea pigs a little bit. Anyway, you should be done, hopefully you'll be done at the very latest on Wednesday building your project, and maybe you'll be done a little bit before that so we can test on Wednesday. And that brings us to the last part of this sheet, which is testing here. So here we have pre-test bridge evaluation and revision. And they tell you what you're going to need to evaluate. You're going to need a photocopy of your final alternative bridge design sheet, colored pencils, bridge abutments, in other words, the place where you're going to put the bridge in between 2 tables or 2 chairs or whatever, and a digital camera, and you're going to take a picture of the top and side of the bridge. You're going to write a pre-test evaluation on the top of one of the photocopied bridge design sheets, and they want you to color code the bridge members on the sheet depending on what you think they'll be under, what kind of forces, either tension, compression, or no load. And that is done essentially by looking at the bridge design, realizing that you're putting the load in the middle here. And when you put a load in the middle here, this member that's going across here is going to be stretched, and so that's going to be under tension. But these ones up here will probably be squeezed, and so they'll probably be under compression. And most of the stuff up on the top will be under compression as this bridge bends downward. Right? And you can actually load your bridge up to kind of see how this works. Anything that stretches, of course, is under tension. Sorry, under compression. No, tension, and anything that looks like it's being squeezed or squashed will be under compression. And then, as you're looking at your bridge and you're testing it a little bit on your own, you should probably decide which members are kind of your weak spots. So looking at different parts of the bridge, say, oh, this part looks like it's struggling, looks like it's bending a little bit too much, or one of my rods popped loose or something, and start writing some things about why you think it might fail if you try to test it completely. And then you can go back and you can improve it, and this is where they have the revised bridge drawings, and these are going to be to scale again. They're saying 1 square equals 1 centimeter. I would say 1 square is equal to 1 inch again. But you're going to revise the bridge design to try to account for those weaknesses, try to make up for those weaknesses and to fix the problem. And then go ahead and do it again. And you can do this as many times as you want before we do the test. But you should keep records of each time you evaluate your bridge before we do the test. So, then we have the post-bridge evaluation, which we will take care of at the end. The post-bridge evaluation involves quite a bit more and will be essentially your final grade for this project. Well, a big part of it. It won't be all of it, but it'll be a big part of it. So, now that we've gone through those next parts that we're going to be doing here now until Monday, I would ask you if you have any questions, but we can't communicate very well verbally. If you have any questions that you want to send to me by email, that's fine. I will keep this link open so I can talk to you as needed. And of course I can answer by email any questions that you ask me over the weekend or whatever. And I'm going to give you the rest of this time. You've got 20 minutes to kind of get started on the next phase of this project. And I, of course, will be in the room, so if you have a question, send me an email and we can talk about it and we'll get it taken care of. Did you have a question? Were you raising your hand? So you have a question. Do you want to send me an email with your question, or do you want to ask your question some other way? Or am I misunderstanding you? You don't have a question at all there in Maxwell. Raise your hand again if you have a question. Okay, no question. All right, well, go ahead and get started on your final big drawing or evaluating your designs if you haven't done that yet. Choose your final alternative design that you're going to use. Start doing your final big drawing, figuring out the parts that you're going to need and what length they're going to be. Start doing some calculations, and you're off and running. You've got plenty to do. Just like the other day, I'm going to go get a drink while I'm waiting for anybody to have a question, and then you have 20 minutes to work on that. And I know you guys are done a little bit early there in Maxwell, so that's fine.
Good class, huh?
Okay, I think I'm disconnected. So I'm going to stop recording.